Okay.
Just a question. The telephone in the support room, is that low volume?
Yeah, let me see if it's on my side. No, I have it at maximum volume. It's a bit low on my side.
I will send you an invitation to join.
You asked about Massimo. I heard that you were asking about the volume. Sorry. I don't know about
no, in
Massimo.
case the telephone comes in, that was basically my concern. Okay, so I know it also. Okay, I will be launching the broadcast, so I will give a very brief introduction, then switch. You can take over.
Okay.
There we go.
The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody, and welcome to this next hot webinar in which Sylvia will present a topic which is maybe not easy to present. It's on how to create your own UCA in Optimus, but it is a very important capability, as we rightfully stress the openness of Optimus as one of our key differentiators. So I think the topic in itself is quite an interesting one, and I'm happy to pass the word on to Sylvia.
Thank you, Luke, for the introduction. So the topic is not easy for sure. So let's go directly to the table of contents of this hot webinar. We will describe what we can do with the UCI and UCA, and you will see how to set up a UCA first, and then how to set up both the input and the output UCI. We will see some tricks on how to check and debug your UCA-UCI system, and how to define filters or rule-based UCI. So let's start with what we mean with the UCA-UCI. UCA, that stands for User Customizable Action, is the way we have in Optimus to connect with the external software and application without the annoying part or rewriting anytime the commands that you need to call the software. And moreover, to avoid the inefficient process that can be very complex to manually define all the parameters in a complex file syntax or in a database, in Optimus you can also implement what is called user customizable interface, or UCI. So the aim of both UCA and UCI together is to deliver an entire roping capabilities in Optimus, and this is really something that can differentiate Optimus from all the other competitors that don't have this kind of openness towards all the application that you want to integrate. But what you see in the graphical user interface when you define your UCA or UCI, what you see is that you have extra icons that you are able to reuse in your workflow and reuse and share with the colleagues. And so this custom integration can be used to create a workflow both for launching the software and to integrate parameter or extrapolate data from the output file very easily and in an easy way. So let's start and see how we can do this in Optimus. So first of all, this is what you can see as a workflow. You can see that you may have three types of interfaces. In this case, in this example is taken from the tutorial that you have in Optimus, and the blue left icon is what is called a UCI input, and from there you can easily connect with the input parameter that you have in the workflow. In the center in yellow you have what is called UCA, that is the node, the icon that is really calling the executable of your solver, and on the right hand side of the workflow you see the icon that is bordered in red. As for every output icon in Optimus, you have the output UCI. And all in all, you see that we can define an entire process, putting together the UCA, the UCI for the input and for the output. What is good is that you can define a UCA, UCI for any OS environment, and moreover that you can also define a UCA that can be run in parallel. So how can we define that? Before starting with a new UCA, you first of all have to create your personal directory, like for example my Optimus, in which you can put all your personal interfaces. In this presentation we will see only files related to the UCA-UCI, but of course in this personal directory you can host also optimization algorithm or response surface methodologies. So you can really have on your computer a directory in which you store all the extension that you can create in Optimus. Once you create and you decide where to put all your personal belongings, you have to define that in the Optimus user.bat file. And on there is an option that is named OPT private user dir, and you can easily define your directory there. Just remember that you probably need administrative privilege to change this file, especially if you install on C programs file directory. And inside this personal directory, you will store, as I said, all your UCA-UCI files. And you first of all start defining three different directories. One for the action that is containing the UCA files, that are the files for calling external programs. One is the configuration files, and the other one is the UCI directory that contains both the input and output UCI files. Let's start from the config folder first. The config folders contain all the files that are defining the structure of the XML file. Optimus is using XML format to communicate with all the other software. But please don't be scared about that, because you really don't need to become an expert on XML file to create your personal interface. In the Optimus installation, there is already all the structure available for the interchange file, and what you need to do is just to copy all these files in your config folder. So the first thing to do is to go on your installation directory, see what you have in a user config file that are the standard files that are used with the predefined UCA-UCI that are available already within Optimus, and you copy that on your config directory. Right now we have 12 files that are defining the formats of the UCA-UCI files, and that's it. So when you have done with that, you can see the structure that I have here. I have the action, the config, and the UCI. Once you have done with the config, you can go directly and start to configure your action, your UCA files. So the UCA file, the UCA directory, contains all the files for all the UCAs that you want to define for Optimus. So a separate subdirectory should be created for any new UCA that you want to create. That means that for any new software that you want to integrate within Optimus, you have to create a new directory at this level. And at this level, you have to create a config file like the one that you see here. And the config file is a very simple file. As you may see, is just listing the UCAs that you have. Like if you have 3 UCA, then you just have like my first UCA, my second UCA, and my third UCA, and you will have 3 directories at the same level. So in our case, we are just following the tutorial, and in this case we are constructing our first UCA. So our XML file will be something like that, in which we have only one subdirectory, and we have to mention that in this XML file. And here it is how it looks like in the structure. So we create a subfolder named trust in our action folder. And you see that we have the config and then the trust folder. If we enter in the trust folder, then that's the level in which you may define all the version available for the same UCA that you have. In this case, we are defining 2 different versions of the trust solver in our case. One is the static version and one is the dynamic version. This is a very important level because, for example, if you are integrating a software that may have different version, like the version 10 and then the version 11 and so on and so forth, and you want to manage that, you do not have to redefine anytime the UCA. You just have to create a new level for that. and this will keep in a very ordered way, in a very systematic way all the versioning of the software that you have in-house. You may see that there is also the option to specify which is the default UCA that you want to use in the list, and the default UCA is also the one you will see first in the graphical user interface. So, having a look again at the structure, you may see now that we have our personal directory like John, and then we have the three directories: action, config, and UCI, and then inside the action you have the truss, and inside truss we have now dynamic and static. So let's see inside one of the version of our UCA what is going on. So let's enter in the static directory, and this file now contains this directory, and the file config XML that is included in this directory contains the most important information about that corresponding UCA. So let's see how the config looks like. Please do not concentrate that much on all the commands that we have. Just I want to give you a general view on how to set it up, and you will have all these slides as a reference, so you don't need right now to concentrate on each single detail of this XML file. But I want to show you that here in your in this file you have all you need to define your connection between Optimus and the program the external program that you want to call. So first of all, you can define the name and the description. The name will be visible in the graphical user interface as soon as you add the node. You can define the icon, that is the icon that will appear as icon of the node, and smaller as the icon as the available UCA-UCI. And this is the important part, and this is the command that you have to call in order to run your program. As you may see here, I have the option written for both Windows 32-bit and Windows 64-bit. Of course, you can also specify the command for Linux, for example. So you may, in one single XML file, you can specify the UCA for any type of operating system that you have. And this is done only once. Here you have the set of parameters that you can pass to your executable that you want to call. In our case, we want to pass the name of the input file, and we want to specify the name of the result file, so that we can have a workflow like that, as you see, with the UCA that has its specified icon and name, and with the possibility to connect and specify the input file and the result file very easily. And on the right hand, you can see what you have, starting from the XML file in the graphical user interface. An important thing is that in the name you can always specify a different language, and for example in our case, if I write like what you see here, like name, trust, static solver, and then JP hello world, what will happen there is that when I open the same XML file, the same UCA in a computer that is running a Japanese version of Windows, for example, you will see hello world instead of trust static solver in your workflow. This means that you can internationalize your UCA very easily. Maybe before you wonder if we can define any other type of parameters, I can show you this. Again, do not concentrate that much on the scripting, but you can see that here we have an example of any different types of parameter that you can pass to your executable. And this is done very easily. We have seen that for the input file, that is an example of a string, but of course you can have the possibility to give an integer value with a specific low and high value as a limit, and or a real value. This is a list of items. This can be very important. For example, if you are connecting an external file that is a solver that contains different type of solvers, and then you may specify this list as option, and you can pick up what you want to run, like steady state, for example, or compressible or uncompressible, and so on and so forth. So different type of solver, or you can have a checkbox like a flag, or a file. So you can browse a file directly from the UCA. And that's it. Once you have defined this XML file, your UCA is ready, and you can do some debugging on that. And I will recommend you that for debugging purpose to turn on your console. I don't know if you are doing that sometimes in Optimus, but if you want to do that, you just have to open your Optimus user bat file, and there is an option there to show console. Just turn it on, write in like set console on, and once you have done, you can have some extra messages on the console. For example, suppose that we have done a kind of typos on the command that we have run. You will have something like that on your console. So this can really help in debugging your UCA. Another error that can happen is that you define an invalid or a duplicated name for your UCA. In this case, a warning message is prompted when you are starting Optimus, and well, you can read that and you can then easily correct what you have done. So that's it. Creating a UCA is not very complex. You just have to specify the commands and the type of parameter that are needed to run that commands. But let's now do a step forward and see how to define a UCI that is a bit more complex. And in the UCI, we have to define two different directories in our folder, and we should specify one directory for the input UCI and one directory for the output UCI. So let's start with the input, and we will see that the output is very similar to that. If we start with the input, we can recognize a very similar structure to the one we have defined for the UCA. Again, for the UCI, you have a first level in which you just list all the available UCI that you have defined for Optimus. And then again, in our case, we have our directory truss. And just having a view of the structure now, inside the truss again, we have the possibility to describe different versions of our UCI, and we can define the default version. And once we enter, again at this level, the final level contains the most important information corresponding to the UCI. So again, we have a similar structure as in a UCA. What is different here is not, again, you can find the name and the description that is again with the option to be internationalized. What is different here is that at the level of the command, you have two very important parts that are the scan command and the substitute. So let's understand together what is the difference between scan and substitute. The scan is what we need to call anytime in the graphical user interface we load the input file that is not well formatted, and we want to load it in a graphical user interface listing all the available parameters. And the substitute is called during runtime. So anytime we want to evaluate a new design, Optimus will substitute by means of this command the value with the current value of the optimization. So let's try to explain a bit more on that. So the scan command transforms the input file that is the standard input file or database, let's say, it can be a database of our external program into a list of parameters that are in an Optimus format. So this value that you see here, this variable Optimus input file, is the file that has the program format, the format that is good for our external executable, and the scan file is an XML temporary file that is created to be read by Optimus. Let's try to explain this with a scheme. So we need to code this scan program in order to take into account the original input file of our executable and to transform that in something that is a temporary XML file listing the parameter in a format that Optimus can read. So in the case of our truss, for example, we have an input file like that. We call this program that we have to code in any type of language that we want, like Java, C, or Python, or whatever. And at any time that you load the input file in the graphical user interface, this program is transforming this input file in something similar to what you see on the right-hand side of the scheme. This file is an XML file just listing, as you may see, the nodes, the name, and the values. So what you see in the graphical user interface will be something like that. The scan is called anytime you click on the button select, you pick up the file. This file, Pennsylvania.imp, is scanned, and the list of entries in the XML file is transformed on something that you can see as a organized in a tree in this list. On the left side, we can also define a filter, and we will see a few slides on how to do that. This is for the scan that is done anytime you select in the graphical user interface. What is doing the substitute is replacing the value of the parameter in the templates file during the run. So again, we have a file that is the input template. Then we have a list of value that is coming from the workflow. That is the list of value that we want to substitute. And finally, the file with the current values. And explaining that in a scheme again, so we have the substitute program that is taking the original input file, is taking the list of value that we have to substitute. As you can see here, like we have the original and we want to substitute the value for material one, then this file is creating the output like that. So once you have coded the program for the scan and for the substitute, you can test this UCI for the input, even if the entire UCI is not completed. And before running, you can just, from the new available icon, just click on validate, and you can see what is happening. If you have an error, this will be prompted in the console. So you can really check what is going on before going ahead with the further steps. So we have construct a UCA, we have construct a UCI for the input. Let's see what we can do for the output, and you can imagine that it's very similar to the input. So again, you have to construct a similar structure in which you enter in the output. Inside the output, you list all available UCI for the output, and then inside your version, you can have the most important file, that is the config XML, listing all the available options for the output. The only difference is in this case, as in the XML, is that here we have trust output as a name instead of input, but it's very similar. And let's have a look at the most important config XML file for the output that is at the final level of our structure. So again, you may notice that we have something similar, like the name and the description and the icon and so on. And now we have two different commands, one for the scan again, and one for the extract. So again, as in the input, the scan is used at the level of the graphical user interface. Anytime you load an output file, is scanning, is looking at what you have on the output file and is listing in the graphical user interface. The extract command is something that is called during runtime. So anytime an output file is available, Optimus, by means of this command, will extract the values from that file, and and proceed with the next step. So, similarly as in the input, you have this kind of command in which you have the output file and a temporary XML file with all the list of available outputs in this case. And again, in a similar way as in the input, anytime that you click on select, this command will be executed. We are scanning what is here called Optimus output file, that is in our case Pennsylvanians.out, and this will create a temporary XML file that is readable from Optimus and is creating a list like that on your right hand side. What is important here is that you can also define vector and not only scalar values for the output UCI. So for defining vectors, you may see how this can be done. Usually we define just entries, but here we can also define vector, and you can define X and Y, and you can keep into account also real and imaginary numbers, so you can keep both on the same and extract that very easily. So, as I told you, the extract is executed during runtime, so for any new design, new experiment, this is the command that is called, and the extract takes the value from the output file and put it in a format that is recognized by Optimus. Okay, and this is the extract scheme. You may see, for example, here we have again the Pennsylvania out. We have the Optimus value file that are the values that we want to extract. And those files are taken into account by our executable, that again can be an executable that we write in C, Fortran, Java, or Python, or whatever you want. And then on the right-hand side is something that show that you can easily extract the values from scalar or vector very easily. So, since again you can test the extraction and in Optimus before running any single simulation. So this can be very easy, as you did in the UCA. And I want to, since to be honest, it's a bit delicate to create a UCI, and both for the input and for the output, before passing to the filters. I want to explain you a bit on how, some tricks on how debugging it. So, for example, if one of the config file is bad formatted, that may happen, like you do not close a tag or you misspell it, then when you start Optimus, you may receive a warning like that you see here, and from that is pretty clear where you have the problem. So, for example, here it's telling me that I have a problem at line 4177 for the input UCI of version 1 of my truss. So I can go there and see what is going on. And again, as a general hint, I would suggest to keep your console on, and I would suggest that you can always use some special command in your scripting, like a sleep command or a pause, or you can also copy the temporary XML file into some working directory to have a look at the temporary files and see and be sure that they are well formatted. For example, here we are running the substitute, and then I'm copying the substitute temporary file in an external file, so I can always check after what is going on. Or you can, as I told you, you can pause in order to have time to check what is going on. So these are some general suggestions that I can recommend to you in order to debug your UCI. So just to complete this presentation, I want to show you some extra features that you can define both on UCA or UCI. For example, on the side of file filtering, you can always define the set of file that you can import. Like, for example, if you are expecting an input file that has a specific extension, you can specify that. So you avoid that the end user can load something that is not really a well-formatted file. So, for example, if you, in this case, I'm defining a filter that is here gives the ability to import only image file format, or you can also define a filter for only PNG extension. Or in our case, in the case of the truss, we can define a filter like that only the .imp file is possible to be loaded. So this can limit the error that the final user of the UCA-UCI can do. But we can also define filters in the UCI input-output at the level of the parameters. This is very important to support the final user of the UCI for finding in a very fast manner the parameter that he wants to change. So once you define your filter on the XML file, your filter will appear on the graphical user interface on the left side of the tree. You can define several types of filter, like filter on the text, on flag, on ranges, as a list, as a dynamic list, as a multi-list. As a dynamic multi-list, there is no time to go deeply on that, but in the next slide we have an example of filters, and the important thing that you have to see is that to use the filter you have to define a tag in the XML input and output file. So once you have done that, you can filter according to that tag in the graphical user interface. And here you will have this slide as a reference, so you don't need to concentrate right now in the entire list. Here you can see that we can generate different type of filters, and what you will have is something like that on the graphical user interface, in which you can, for example, filter with a text and write the name of the variable that you are looking for, and this will filter the tree on the right side, and only the variables with that name will be visualized. That is really helpful when you have a very complex project with several parameters. As last slide of this presentation, we have another way of defining a UCI, both for the input and for the output. It's a rule-based UCI, and in this case you really don't need to write a single line of code. You just have to define the XML, but this input-output UCI only is only available, can only be used if you have output ASCII files that is structured and fixed with a precise number of rows and columns, and with a number of input and output variables that is somehow defined. So, for example, suppose that we have a solver that gives out only the displacement and is formatted in the same way, and we only want to extract and for the rest of the life for our UCI we want to extract only the displacement. Then in that case you don't need to code, you just have to specify the rules of extraction in your graphical user, in your XML file, and in your graphical user interface you will see the list of displacement on the right hand. So this is what we call rule-based. It's very handy. Of course, it's limited to some specific case, but in this case it's maybe very handy because you don't need to code a single line of program. So I hope that it was not that hard to follow. I understand that there was a quite long list of XML code, but I hope I didn't scare with that. I told you that you don't have to really concentrate too much on that. The XML code is always available as a structure, and we can leave this presentation as a kind of tutorial for that. So I hope it was helpful, and please do not forget to join us for the next webinar that will be on the 11th of June and will be about some advanced workflow capability in Optimus.
Okay, thank you, Sylvia, for your presentation. I think this is typically a topic which will trigger questions if people want to develop specific UCAs and UCAs, and so I invited people joining today that if they have any specific questions to specific UCIs or UCAs, they can contact support by email to consult about that. We did have more general questions coming up, which is that if you select a file in a UCA, is it copied to the project directory or is the absolute path being used?
Can you please say that again? If you copy?
Yeah, if you select a file in your UCA, is it copied to the project directory or is the absolute path being used?
It depends on how it's defined in the UCA. It is usually copied on the current directory, so it's the project directory, but it may be referring to a path. So it is usually based on the current directories, so it's the project directory. But it depends a bit if it is a temporary file. Maybe if I see the script, maybe I can be more precise.
Okay. So that indeed, I think, confirms that if you have any specific questions on this, do not hesitate to get in touch with people over here in Leuven who will be happy to help you out with any issues related to UCA development. I think this concludes today's hot webinar. I would like to thank you, Sylvia, for the presentation. I would like to thank all people attending today. And yeah, next meeting is in 2 weeks from now, in which Max will deal with some of the more advanced workflow capabilities, loops and switches in Optimus. So have a nice day.